An MP4 file does not only store the media data that we see on our screen and that we hear when listening to maybe the audio that is within that MP4 file. There's quite a lot of information that is stored within an MP4 file that relates to the actual data, which would be the video that we are watching or an audio that we are listening to. So the data, basically the actual data, the video would be stored separately from the data that relates to it. The data that relates to the actual data is basically the data about that data. The information that relates to the actual data would be information such as the camera that was used to take your videos, the encodings that were used to encode that data, the number of tracks within that MP4 file, and the creation date of that file, the last modified data, if there are any copyright, the copyright owners, the genre, and all information that relates to the actual data is basically stored separately from the actual data. So the actual data is basically stored on the media data box. This is media data box, is MDAT. That's where the actual data is stored. Your audio is stored there, your video frames are stored there, and there it's only that data. But because it's just an array of bytes here, it's just an array of bytes in this, which is basically the actual data. So you have to know within this array of bytes, where is the video, where are the video frames, and where are the audio samples, and you get that data from the other boxes. And a lot of that information, such as that will be stored on the move box, will be stored on the boxes that are found within the move box. There are a number of boxes that are found within the move box, and all those boxes, they actually contain information that relates to that actual data, and information that is stored within these boxes will also be able to tell you in that media data where you are going to get this type of information, where you are going to get your audio samples, and where you are going to get your video frames, where the number of frames that are taken per second. It will tell you the width and height on all those sort of things. But what we need to look at before we go into details into that information, we have to know how to read out these boxes. It's very important that you know, okay, how do I read out these boxes, and how do I get the data that is stored within these boxes, and where do I get what data in these boxes? Does that make sense? So now we are looking at how to read an MP4 file. We're looking at the code to do the actual reading of an MP4 file. So the first thing that our code does is simple. We have a method called getMedia, which we are going to call when we are actually opening the file that we want to edit. GetMedia as its parameter will take the full path to the file. So we read all the bytes of that file, and we save them to a variable called MDAT. So now we've got a series of bytes within that file into our MDAT variable, which is media data. So in our code, we also have a method that we call get all boxes. Get all boxes does nothing special. It just reads the first generation of this MP4 file, the first generation of boxes of this MP4 file. If you are following along, you'll remember that we said an MP4 file is basically organized or ordered into a set of boxes, which could be which forms something that is similar to the family tree, where there's first generation and the second generation, the third generation, something like that. So here, get all boxes just give us the first generation of boxes, and then we can move from that first generation to any generation of boxes depending on what we are looking for, because each box has a certain type of data or of content. So, for example, some boxes are used to store information about the samples within our file. Some boxes are used to store a lot of information that is related to the actual to the actual file. So get all boxes will just give us the first generation of those boxes. So let's go and look at what get boxes looks like and how does it get this first generation. We'll just go to the definition. This is how it looks like. So we get the first generation of boxes, the all boxes accept as its parameter an array of bytes, which is basically the bytes of the file, and then we create a stream to those array of bytes of the file, so that it's easy for us to read these things. So we have a list of boxes. We basically have created a class that we are going to use to store the things like the offset of the of the box, from which each box is found, the size, how big it is, and other and the name of that box. Those are the three properties that we store. This is a custom class. So we loop through using a do loop. We loop through this string, reading these boxes out. So when we read, the first thing we declare the box info bytes. The box info bytes is basically the bytes that contain the name and the size of the box. And then we read into box in bytes. We read these 8 bytes, and then we call another method which we call getBoxInfo. GetBoxInfo is just going to convert these bytes into a name, and into a readable name, and a size, so that we know how big this box is. And then we add these to a list of boxes, to a list of child boxes. We add each box. Each time we read a box, we add it to this list. We record the name, the size, and the offset, so that we know from where from where within this byte stream this box is found, and how big it is, so that we can know how much we must read to get to the end of each box. And then we move the offset by the box size that we have just read, so that we get to the next box. Because the offset and the size of each box will actually, the sum of the offset and the size of each box will actually tell you where to start reading the next box. And then we change also, which also change the position to the box offset, because if we don't change the position, what is going to happen the next time we read, we'll read to the wrong thing. We'll be reading the contents of the, we are more likely to be reading the contents of the box. So we have to change the position of our stream to box offset. Box offset, remember, box offset is basically the previous box offset plus the size of the box that we've just read, which takes us to the next box. Then we come again and we do the same thing. We get the bytes which contain the name and the size, and then we ask the box info method to give us to convert those to a readable name and the size. Let's go to box info to see how it looks like. Again, it's a box. We create a length and the name. So we read the first 4 byte. The first 4 byte is the length. We read the first 4 byte and then we reverse those array because the sizes are basically stored in a big Indian byte stream. So we have to reverse them to get the correct length, and then we read the name of that of that box, and then we convert each byte within the name array of bytes, converting it to be a character to create one name. So here it's going to give us the name of the box, and then we record the size by converting the length by converting the array of bytes which represent the length of the box, convert it to an integer, and we return it to the caller. Now our box, when this method returns, now the caller will be having the name of the box and the size of the box. Now the caller will know from where this box is, will know the name of the box, the size of the box, and the offset of that box. So we're going to look at this in practical. We'll run this code and we'll work with you to add more things. We'll show you how to get the frames out of this file. But that's it for now.